Hello, in this lesson, we are going to talk about collinearity of 3 points. So, 3 points are said to be collinear if they lie in the same straight line. So, if we have points like A, which we can assign it values like x1, y1, and point B, which we can assign it values like x2, y2, and point C, which we can assign it values like x3, y3, these points are collinear if they lie in the same straight line. So, to understand what it means by straight line, can we give them first real values? So I can say here is 1, 2, where 1 represents x1, then 2, y1, then B is, can say for 5, where 4 is x2 and 5 is y2, and then C is 7, 8, where 7 is x3 and then 8 is y3. If I try to plot these points in a graph, like this, 1, 2, for point A, then point B for 5, then point C, 7, 8, and then I plot them, you see, they are like one straight line, just equidistant from each other. So if I confirm their collinearity, you see, all of them are just in the same line. So we can use graphing to check if points are collinear. But most of the time, we will not use graph. We'll need to use a formula, and that's why we are supposed now to develop the formula of checking collinearity. Then afterwards, we can use that formula to solve problems relating to collinearity. So can we do that? To do so, we need to develop a 3x3 matrix. And when I mean 3x3, I mean a matrix which has 3 rows and 3 columns like this. But these 3 rows and 3 columns, we also need now to reduce that matrix into a 2x2 matrix. And to do so, I just need to pick one row and use it as the scalar values, which I'll put them outside the 2x2 matrix of each of the values. So let me show you what I'm saying. So you see, this is our original 3x3 matrix. And by the way, I developed it using just the normal variables we had, where we had the variables for A as x1, y1, the variables for B as x2, y2, and that of C as x3, y3. And then this one I've put here is to complete the geometry of this matrix, and I'll teach about that one in another lesson. But for now, know that in this formula, we need to add a 1 at the end to make the matrix be a 3x3 matrix, which has, of course, 3 rows and 3 columns. So now, since we have the 3x3 matrix, can we reduce it to 2x2 matrix? And to do so, I need just to pick I can pick the first row here. Me pick the first row, this one. And then if I pick that first row, I'll just pick x1 to be outside. Then if I pick x1 to be outside, I need to delete the row and the column which has x1 like this. So you see, I've deleted x1 is in the first row and it's also in the first column. So I've deleted both of them, and I've only remained with y21, y31. So I pick those values and put them here. So it becomes y21, y31. So I repeat the same for y2, y1, which is the one, of course, we picked the first row. So I repeat that with y1 and I put it outside here, y1, like this. And then I pick the values remaining. I cancel the row and the column with the y1. Then I pick the values remaining. So you see, I've cancelled the 2 rows. And what is remaining is x21, x31. So we put them inside here. x21 and then x3, 1. like that. And then finally, we pick the last value in this first row, which is 1. So after picking 1, we can put it here, and then we pick the values remaining after cancelling the row and column containing that 1. And if we do so, we have cancels the row and the column. We remain with x2, y2, x3, y3. So I pick them and put them here. x2, y2, then x3, y3. And now that we have the 3 matrices for each of those values, now we can find the determinant of each of these 2 by 2 matrix. And how do we do that? If we start by the first matrix, where we have y2, 1, y3, 1, and x outside, you just need to pick this y2 multiplied by 1 minus y3 multiplied by 1. So it becomes x1, which was outside, of course, in brackets, y2 multiplied by 1 is still y2, then minus y3 multiplied by 1 is still y3. And this becomes the determinant of that matrix, but we multiply by the scalar which we had put earlier. And then we repeat the same for the second one, which was having y1 outside. Then we take x2 multiplied by 1 minus x3 multiplied by 1, which becomes y1 outside. Then in brackets, x2 multiplied by 1 is x2 minus x3 multiplied by 1 is x3. Then becomes the determinant of the second matrix multiplied by the scalar. And then the third one, of course, it had 1 outside. Then we pick the values remaining, which are x2, y2. So x2 multiplied by y3 is we can put it like this: x2, y3 minus x3 multiplied by y2. So which will be x3 multiplied by y2. That becomes the determinant of the third matrix. From there, now we need to put all these values in the formula of the area of the triangle formed by those 3 points. So the area is given by half, area of a triangle, half into the first matrix, the first determinant of that matrix, but we have the scalar outside, x1 into y2 minus y3 minus the second one, which is y1 into x2 minus x3 plus the third one, which is 1 into x2 y3 minus x3 y2. Don't forget, I started with minus, then the third one became plus. Don't forget that. So this becomes the formula. But as you can notice, I ignored the 1 here because if you multiply any value by 1, it still remains to be 1, so we will need to put the 1 here. But you have to put the x1 and the y1 here. Well, now that we have the formula, the only thing you need to check is if you replace the real values of those 3 points in that formula and the answer is 0, it means those 3 points are collinear. If the answer is not 0, those 3 points are not collinear. So that's how we check the collinearity of 3 points. So can we try an example? And we start with our first points, which we actually verified using a graph that they were collinear. We try to replace these values in the formula and see if it is actually they are collinear. I have into x1 is 1 into y2 minus y3, and our y2 is 5 minus y3, which is 8. So 5 minus 8 is negative 3. Then minus y1, and y1 is 2 into y2 minus into x2 minus x3, and our x2 is 4 minus x3, which is 7. So 4 minus 7 is negative 3, and then we have plus y plus 1, which we don't need to put it here, but then in brackets minus x2 y3. What is x2 y3? Our x2 is 4, and then y3 is 8, so it is 4 by 8, which is 32, minus x3, which is 7, by y2, which is 5, so that minus 35, and that 2 minus 35, of course, is negative 3. So if I write it again here, it will be half into minus 3, minus 2 multiplied by negative 3 will be plus 6, then plus the 2 minus 35 is also negative 3, then it becomes minus half into negative 3 plus 6 minus 3. It becomes half of negative 3 plus 6 is positive 3, then positive 3 minus 3 is 0. So half of 0 is 0. And if you get the area is 0, those 3 points are collinear. So can we try another example? Let us try question 2, which we are points. You can call them A as 2, 3, then B, which is 4, 5, and then C, which is 6, 8. So this is x1, this is y1, this is x2, this is y2, this is x3, this is y3. We'll replace them in the formula direct because we know the logic of the formula. So area will be given by half into x1, which is 2, in brackets y2 minus y3, and we already know y2 is 5 and y3 is 8, so 5 minus 8 is negative 3, minus y1, and y1 is 3, in brackets x2 minus x3, which is x2 is 4 minus x3, which is 6, so 4 minus 6, which is negative 2, and then we have plus the last one, which is x2 y3, x2 is 4 and y3 is 8, so 4 by 8 is 32, minus x3, which is 6, by y2, which is 5, so 6 by 5 is 30. So like that, then it becomes half into 2 by 3 is negative 6 there. This one minus 3 multiplied by negative 2, it will be plus 6. Then that 2 minus that is negative 2. So the answer becomes half of minus 6 plus 6 is 0. Then minus 2 is negative 2. And the answer becomes half of negative 2 is negative 1. I'll cancel this 2 by this. So it becomes negative 1. As since the area is not 0, these 3 points are not collinear. So can we try to put them in our graph and see if the line will be straight? If the line will not be straight, it means they are not collinear. So can we start with 2, 3? Let me start with 2, 3. Then the second point is 4, 5. Yes, 4, 5. Yes, it's okay, that one. And then the last one is 6, 8. 6, 8. And then I plot the point. So you see the line is not straight. It doesn't bend somewhere here. 4, 5. So the lines are not collinear. If they were collinear, all of them, the line would be straight like this. It would be straight like this. Like this. Can you try question 1 and question 3? to see if you have understood the concept, and let us meet in the next